Hello everyone, welcome to another video which is about cycle geometry. Today we're looking at the grade of November 2022 question paper 2, specifically question number 9.1. We're given a diagram which I've tried to draw. In the diagram we are told that there is a cyclic quad which is D, E, F, G. And then this cyclic quad has two parallel lines, DE and GF. They mention that DE is produced such that it continues to point R. So this is a straight line. And then T is another point on the circle. So that is your T, and it lies within the circle. EG, FT, and ET are drawn, so these are other lines within the circle, and we're given two angles. The first one is E4, and the last one is G1, which is 16 degrees. E4 is 72 degrees. All right, let's start with the first question. First question is asking us to calculate and must provide reasons of the angle DGF, so that is 9.1.1 DGF. What is that angle? So as you'll notice on the series of cycle geometry, I mentioned different things or different pointers centered around cycle geometry, and one important thing is the definition of a cycle quad and how you can use different approaches or different theorems centered around cycle quad to better understand and calculate effectively the angles that are needed. So DGF, which you might already assume or look at the diagram, is forming part of the cycle quad, and the point where it's at in the cycle quad is very much important. So if we look at DGF, this is DGF, and if you struggle with reading angles, this is very common, you must understand. We are sometimes given angles in numbers, so E1, E2, E3, E4, but sometimes we are given these angles as a direction or a location rather. So if you look at, for this question, if you look at DGF, this is a location of the angle that is concealed by the straight lines that are meeting at point G. So DG is a straight line and GF is a straight line. So if you look at where they intersect, you look at the whole angle that they form. So that is your angle that is needed. So that is your DGF. So we're asked to calculate the value of that angle. So where is that angle? Like I mentioned to you, this angle DGF forms part of the cycle quad there. So it is this angle, and it is also part of other angles, which is your F1, this entire angle DEF, and also angle EDG. So all those angles are forming part of the cycle quad. What are the theorems around the cycle quad? There's many of them. One being that opposite angles on the cyclic quad, they sum up to 180 degrees. And another one is that in the cyclic quad, the exterior angle of a cyclic quad equals to the opposite interior angle. So there are many of these. Others, you have angles subtended by the same chord. Within a cyclic quad, those angles are equal. So there's many of them. I'll attach a link to more videos around this specific issue, which is cyclic quads. In this case, if we just look at the location of DGF, we already see that, DGF is opposite also is opposite DEF. So this angle and this one should sum up to 180 degrees. But do we have this angle? No. So we'll move on to another theorem. So you look again, I see that there's E4, and E4 is the exterior angle of this cyclic quad, and the opposite angle of So if you look at the opposite interior angle of the cyclic quad, opposite to E4 is DGF. So we already see that E4 should be equal to DGF. So DGF should be equal to E4, which is equal to 72 degrees. 72 degrees, and the reason being exterior angle of cyclic quad is equal to opposite interior angle. So it is important to provide reasons, just like how the question is structured, but it is important to yourself, but also helps guide the marker, whoever is looking at your script, about your line of thinking. Some people might solve this question differently, but the most important thing where we all combine is the reasoning. Can we understand your reasoning? So we have the answer, DGF, that it is equal to 72 degrees. The next question is calculate the value of T. 9.1.2. We are asked to calculate the value of angle T. T. You might ask yourself, why is it only called T? So what helps with choosing angles in terms of location, just like how we looked at DGF, is if you have multiple angles, for instance G1 and G2, how do you go about, let's say if you haven't labeled them, how do you go about naming those angles, or saying, okay, which angle am I calculating? In the case of T, there is no multiple angles around here. There's only this value or the opposite, or the one that is outside of T, which we're definitely not looking for that one. We're specifically looking at this value in here. It is also not wrong to say that is angle ETF or FTE. Still the same angle. In this case, we're asked to calculate the value of T. So T, the first thing you should already notice is that T is forming part of that butterfly. You opened your mind and you figured out there's many theorems within cycle geometry, but also it helps to identify just by the shape of something that this is probably aligned to a certain theorem. So you see T, you're already seeing the butterfly. So T should definitely be equal to G2, but what qualifies the same man? These angles should be subtended by the same chord or arc. So there is your EF. This is a chord because it starts from the circle, within the circle, so it also goes to, it touches the circle on both sides. So that is your chord. But also, if it was not there, but we still had the benefit of the arc EF, the reasoning still stands that T should be equal to G2. But do we have the value of G2? You ask yourself, is this the easiest path, or is there any other reasoning I could have went with? But we've already just calculated the value of DGF. So we do have the angle here. We have our G1, therefore we can calculate G2. So let's start at the beginning. T is equal to G2. The reason is that these are angles, you can't say butterfly in here, unfortunately, angles subtended by the same arc or chord, and then you name that arc. Angles subtended by same chord. What is that chord? It is your EF. These angles are equal. Same chord EF. That's your chord. Those angles are equal. But we don't have the value of G2, so how do we go about calculating G2? Like I said, G2 forms part of DGF. When you sum these, they should give you 72. So G2 plus G1, this should give you 72 degrees. And to calculate the value of G2, you take G1 on the other side. So G2 is equal to 72 degrees minus G1. What is the value of G1? It is 16 degrees. So 72 minus 16, that is going to give you, if you calculate, it's going to be giving you 52. So that will be your 50. No, is that your 52? So 72 minus 16, that's gonna be 62 minus, so it's gonna be your 56. The answer is 56 degrees. Alright, so we figured out the value of G2. Therefore, angle T, which you must not forget, angle T should be equal to 56 degrees. Alright, so we move on to the next question, which is asking us to calculate GEF. Angle GEF. Alright, so where is angle GEF and what does it do, or what influence does it have on the entire diagram? So we have to look at this. So GEF, we already know how to locate angles now, and we should start with the analysis side. So this is the angle we're speaking of. Where is this angle? So in the question, in the answering of where is the angle, you start figuring, okay, which theorems can I use here? What shape does this form? And as soon as we look at shape and think, okay, no, this shape looks like a certain theorem, then we know we should definitely touch into that. But if we don't find that, or if it is the long process, then we start using other means to find the answer. So GEF is this angle, and this angle is still within the cyclic quad. That's the first thing you note. In the cyclic quad, you know that the opposite angles are equal to 180. So you know that if I have this one, I can find this one. But we're not looking for DEF. We're looking for GEF, so this one. So we need to find this guy before we can start looking at what is the one that we're looking for. Alright, so the goal is to find this. Now that you've changed the approach to finding E1, you start looking what shape or where is the location of E1. You see that E1, we can think of other theorems, but it's going to be really, really hard. We can think of a butterfly, but there's no butterfly here. We can't find any other arc or any other chord. So we must use other means or other information that we've given in the diagram. So another thing we should note is that DE is parallel to GF. Soon as there's parallel lines, you start alternate angles. That is your Z. You start looking at corresponding angles. That is your F. And you start looking at your U, which I call U, which is the opposite angles. Sum up to, or we call them co-interior angles, or those angles sum up to 180 degrees. Now, when you're looking back here, the shapes that I've just told you, you can already see that the first shape in here is going to be your Z. So this is your Z. Let me use another marker. There is your Z. There is your Z. Alright. And we see that with this Z, G2 should definitely be equal to E1. So that is the first answer. So do note E1 first step is equal to G2. The reason, alternate angles. Because, so when you mention what theorem or what rule you used, you must mention which lines are parallel. And why is this important? At least for this one, it is not much. It's obvious which lines are important. You might get diagrams in the future where there's plenty of lines that are parallel and specific lines, if I may explain further. So you need to be able to note to the marker or the person who's looking at your script that I used specifically these two lines to locate that angle. So this is DE parallel to GF. Alright, and do know this is not magic. This is us just blowing our minds with these different skills we've learned in circle geometry. And the better you practice, the better you'll be at solving these questions and pinpointing which theorems to use. So now that we've found G2 or E1, then we are already excited in that we can now start using opposite angles of a cyclic quad. And another one is that we can start using these parallel lines here. So it means this angle and this one, they must sum up to 180, that is your U shape. Another one is that there is this straight line that we're told about, DER. So the angles in here should sum up to 180 degrees. So it's up to you to choose which path is the easiest. So I'm very much a simple man. So I look at a straight line, I see simplicity. So if we look at a straight line DER, we have angles E1 plus the angle we're looking for, G, EF, and then we have E4. Those angles are to form 180 degrees because angles of straight line equals to 180 degrees. And you can mention the straight line for interest's sake, that is your DE or line DE. You don't have to mention DER, or you can say DR or DE or ER, or that's still a straight line. So we have E1, we just calculated E1 equals to G2. We have E4, so we can find GEF. So GEF is equal to 180 degrees minus E4 minus E1. And this, we start substituting what is E4, so 180 minus E4 is going to be 72 degrees, and E1 will be your 56 degrees. So what is the answer to that? So we can just easily calculate that. So 180 minus 72 minus 56, that is 52 degrees. And always remember, guys, just because you can calculate it by your head doesn't mean you should do it. Use the tools that you have to make the process faster. So we now know that the answer is 52 degrees. And the most important part in all of this is understanding the procedure, the reasoning, and making sure you use your mind, your creative side, and also you use your mind that better utilizes diagrams, colors, and everything to pinpoint or give you a direction to finding the answer. Those are the most important things in circle geometry. Thank you.